Hi, this is Johnnie. I'm going to go over Math Assessment Task 4, Assessing Students' Mathematics Learning, and this is coming from the edTPA Elementary Education Assessment Handbook. I'm going to focus on the what to do list over here. And I'm not just going to go through this list and say what's here. I'm going to give examples along the way that might help you as you organize yourself for the assessment task. So I'll start over here. The first bullet says, select one class as a focus for this assessment. That should be your homeroom class, the class that you're doing your placement fieldwork in right now. The second bullet, provide relevant context information and a learning segment overview. The relevant context information should come from your Context for Learning form that you submitted for the overall performance assessment. But this also asks that you add a learning segment overview. Whereas the Context for Learning focuses a lot on the kinds of things that are happening in the classroom around literacy, it would be good for you to include similar information around the mathematics program. Now the third one, and these first three are not that difficult to manage. The third one is identify a learning segment of 3 to 5 consecutive mathematics lessons. And the importance here is that they're all together, 3 to 5, and they follow one another obviously, but they're all about something that matters. So let me put up a summary just of this first set of things. These first three bullets, just one class, include the context for learning, and also describing some kind of information around the mathematics program in your classroom. And the third bullet, make sure this assessment comes from one set of lessons, right? So that part is easy enough. We're going to get to the fourth bullet now, and this is where it gets a little bit more complicated. Identify a central focus. The central focus should support students to develop conceptual understanding, procedural fluency, and mathematical reasoning problem skills. So let's take this one apart because it's a bit of work. The first thing is we need to think about what a central focus is. And here's a question that might help you to organize that for yourself. The central focus. What do these lessons intend to teach? As a result of these lessons, what will students be able to do? What will they know? What can they show you in terms of their mathematics? And I've given you a couple of examples here. The central focus of this sequence of lessons was to build student understanding of the properties of shapes. Students were to learn the features and names of quadrilaterals. All right, so you get the idea that it's a mathematical topic, and it's got some breadth and depth to it as well. I'm going to talk about that in a moment. A second example, the central focus for this lesson sequence was to develop understanding of fraction operations. Students learned to build like fractions when adding and subtracting unlike fractions. Again, you can imagine that coming from a sequence of lessons. It's worth teaching, and it has some depth to it as well. What matters here in this portion, and we're going to get to the more important part right now, it says the central focus should support students to develop conceptual understanding, procedural fluency, and mathematical reasoning problem-solving skills. Let's keep the central focus in mind. Let's add something to this. Let's make sure we have this list of important things at our side now. These are going to matter throughout the tasks that you do, this particular task, the assessment task. Conceptual understanding, computational procedural fluency, and mathematical reasoning problem skills. So when you decide on your central focus, you want to try to have these three, our friends, in that. Now if we look at the two examples I shared, the central focus of the first one was around properties of shapes. Now you can think about that in terms of conceptual understanding pretty well. The properties of shapes have to do with their naming and attributes such as whether they're parallel lines, or there's types of angles, or the numbers of sides, or the relationships of the angles to the sides, whether they're regular shapes or other kinds of shapes altogether. And quadrilaterals have their own particular attributes. So in this, you can see conceptual understanding would be addressed with this particular central focus. Computational and procedural fluency be a little bit more difficult here, and maybe it's not quite so appropriate here, but definitely the last one. Mathematical reasoning and problem-solving skills would definitely show up in this one. When you'd have to sort the shapes based on their attributes, you'd have to make comparisons, and you can imagine problems where you have to decide which shapes are of a particular type, which ones have how many sets of parallel lines, what types of angles, etc. So there's opportunities for problem solving in this as well. So the central focus, as I said, should be something about what kids are going to be able to do and know as a result of the math lessons. But you want to make sure the central focus sets you up to have these kinds of considerations in the teaching. All right? I'm going to leave these three here because they keep coming up again and again. Let's look at the next bullet. It says, develop or adapt a formative assessment from the learning segment that will allow you to assess whole class learning. The assessment should provide opportunities for students to demonstrate conceptual understanding, computational procedural fluency, and mathematical reasoning problem-solving skills. Our friends over here again. So let's keep them in mind. But this develop or adapt, we need to take that apart a little bit. Developing means that you'd have to do a lot of work on your own, and it may not fit with the program that's already in place in your classroom. The alternative is to take what's given in your math program in your classroom and use that to do your assessment and then your analysis. The problem with that is that a lot of the assessments that come from the standard curricula for math don't necessarily ask the rich kinds of questions or set out the kinds of evaluative criteria that will help you to do well by this task. So you need to think about how you're going to adapt it. I'm going to give you some ideas about that. So if we look here, for the math assessment task 4, you may take an expected math assessment in your classroom and make it work for this task. You want to adapt that assessment, and here's the critical part. You want to clearly define assessment criteria in that assessment that will allow you to do rich analysis along our three friends again: conceptual understanding, computational procedural fluency, and mathematical reasoning and problem solving. So whatever you choose to use, just imagine yourself making it better and adding some things or setting some frames around it that will help you to do some really good math teaching, but also some good analysis as well. So let's go on to the next bullet. It says, submit a blank copy of the assessment used to evaluate student performance. Well, I'm going to share some examples with you. We'll keep our friends here just in case. And I have a couple different grade levels that we can look at. I'm going to start with a primary geometry assessment. And it might look something like this. And in this particular one, you can see that students will have to draw a shape, write its name, and then describe its attributes. In this particular assessment, this was to be done with 6 different shapes. So you can imagine this being a 2-sided sheet, and the students would have to do this for 6 different shapes. Now, this is the blank copy, but now I'm going to show you some other things that go into the next bullet point, which is define and submit the evaluation criteria you will use to analyze student learning. So this may be the assessment, but that's not all we want. We want to know how it's going to be measured. What are you going to be looking at as you analyze the student's work? And so here's a rubric that was set up to go with this particular geometry assessment for, say, first graders. You can see that it's broken down into 3 different sets of criteria, one around naming, one about describing attributes, and one about drawing. And it fits nice and tidily with the actual assessment. And so one virtue of this rubric and the assessment is the alignment between what is asked for or described within the rubric and what kids might do. Let's look at how this is constructed. In this particular rubric, it's constructed from mastery to incomplete. A lot of rubrics will go the other directions, from left to right. That's up to you. But you can see under incomplete, student did not complete the assessment. This is for write it, or give it the correct name. Under beginning, for write it, give it the right name. The requirement for this level is that student gets 1 of the 6 shapes correct. Under 3, developing, 2 out of 3 shapes. Under 4, 4 out of 5. Under 5, 6 shapes. I'm not quite clear on how these numbers ended up this way, but you can see there's a progression from not being able to do anything to progressively being able to do more and more in regards to that particular criteria. And so it would be easy enough to assess these in terms of was the student able to do this or not, and you could easily mark based on this rubric. Now, before I go on to a different example, I want to make a note of caution here. When you set out a rubric that's like this is about right or wrongness. It's very much about did or didn't do, and there's no qualification to how things were done. So the only problem with that, or the significant problem with that, is that in the rubrics for the assessment task, just saying or just describing kids as having done something right or wrong is a low mark on the rubrics for assessment. You want to have some qualified statements too about how they did things. So this has some virtues here, but it also has some limitations. So I'm going to show you a different assessment now, and this is maybe for a second grade class. So here's the assessment. You can see that it's about measurement. We have two penguins here, rockhopper penguin and the king penguin, and the students would be given paper strips or paper rulers to measure these as part of the assessment. Then they're to mark the relative heights in each of these bars, and they make comparisons. What's good about this is after they've done that kind of work, they have to do some thoughtful work down here about comparing using greater or less than signs. And then they have to do some computation down here as well. If we go back to our friends over here, there's opportunities for conceptual understanding in terms of, so you've measured the two penguins, how do those compare? So some conceptual aspects to it there. Computational procedural fluency and how clearly or accurately they measure, and some reasoning skills down here when making the comparisons. So this assessment has a bit more going on. The evaluation criteria are here. They're okay, but not really that great. First off, it would be good to have the piece that is being shared with the readers for your edTPA assessment to have really good, clean copies of things. But if we look here, the students' names would be here, and the 4 criteria are correctly measured height, measured with precision, correctly recorded height, correctly compared height. Again, the difficulty with this particular set of criteria is that they're just about right or wrong answers. And that could be a difficult thing to analyze if that's all you're looking for. And it will be difficult with one particular rubric that will be about how kids think about the math, not just whether they're right or wrong in things. So this is a second grade assessment. You can see its virtues and maybe some of its problems as well. Let's put this one away, and I'll give you one more to think about. This is an upper grade assessment. And unfortunately, I don't have the assessment or the evaluation criteria, but I am sharing this for a particular reason. If we look at this assessment, you can see that it sets out learning targets. In the 3 bulleted items, you can see how the math is described, the kind of work is described. The first one says, I can analyze equations and look for relationships between multiplication and the division of fractions. The second says, I can reason about and solve problems that involve the division of fractions by drawing models and creating equations. And the third says, I can interpret and compute quotients of fractions. Now what's nice about these 3 bulleted points about the learning targets is they map well to our friends over here: conceptual understanding, computational, procedural fluency, and mathematical reasoning and problem-solving skills. So there's some analysis that goes with the problem solving. The reasoning also fits with the solving word problems here. And of course, because they have to do the mathematical work here, there's going to be some computational or procedural fluency. Now, some of the conceptual understanding is going to show up within the problem itself. So I'm going to read the problem, and you can see why it's a worthwhile problem. Molly, Hallie, and Ricky were working on the same problem, but they all got different answers. They each argue that they did the problem correctly. Who was correct and why? Justify your reasoning. So you can see again the 3 areas we care to look for: conceptual understanding, computational, procedural fluency, and mathematical reasoning, problem-solving skills will show up in this problem. This justify your reasoning, who was correct and why, make this a rich task. So here's a little advice about the kinds of assessments you might choose. You want to choose an assessment that offers students ways to think about things in mathematics a bit deeply and to be strategic in their mathematical reasoning. The other thing you want to think about is that you want to set up the problem so that students have an opportunity to work things out. So these problems aren't just going to be simply solve them and then I have an answer. They're going to have to be compared, because you're supposed to say who had the problem correctly and why. So all of this space will show all the students' reasoning, okay? And it fits under here where it says by drawing models and creating equations. So lots of student work is going to show up on this assessment. And since a lot of student work is showing up on the assessment, the evaluator or the teacher has a lot to look at and respond to, both in feedback and in the analysis of the assessment. So that's why I shared this one, to help you think about what kinds of assessments you might want to look for. Now, let's go to the next bulleted point here. So we talked about submitting a blank copy of the assessment. We talked about defining and submitting the evaluation criteria you will use to analyze student learning. Let's take that one a little further before we go to the next bulleted point, actually. I have something else to share with you. So I've given you these examples of evaluation criteria and some student work. Let's push on the evaluation criteria a bit. Here is a different kind of rubric that might be used. Now this one is a much broader rubric, and it could be used for many kinds of math assessment tasks. But you can see that the evaluation criteria are broken down along procedural fluency, conceptual understanding, problem-solving, strategic reasoning, and then communication and representation. The first three obviously fit with the ones we've cared for so much along the way. The last one is useful because it insists that the students represent their ideas, that they're not just giving answers without showing work. And communication is one of the aspects of mathematics we want to develop in our students. So having them pay attention to how they're representing their ideas in the assessment will help your analysis as well. You also can see how each of these criteria are described in terms of developmental levels. Emerging, each is described in terms of their developmental level: emerging, developing, proficient, and exemplary. So for example, under procedural fluency, an emerging status of work would be attempts to use appropriate procedures, may use inappropriate procedures. Developing would be uses procedures correctly but makes computational errors or other slight errors. And proficient would be student shows work step by step with correct computation. And the last, student uses correct procedures that result in good solutions and checks work. So you can see that the exemplary goes a bit beyond, and developing and emerging are a little bit short. One's much more short, and developing a little bit short of what's considered proficient. If you're developing your own rubric for this kind of work, you should start with describing the qualities for each criteria under proficient. You're saying what students should be able to do as a result of your teaching, the expectation for what kids should be able to do and know about that mathematics as a result of your lesson. So by defining these first, these criteria under proficient, then you can work backwards about what might be developing or what might be emerging, and then you can also describe what might be a little bit more under exemplary. So that's another way of thinking about defining and submitting the evaluation criteria. Now let's hold on to this one because I want to go to the next bullet point now. It says, summarize the class performance on the formative assessment completed during the learning segment. Now I'm going to show you two ways to do this, and they're quite useful, both of them, but they do different kinds of work. The first one I'm going to share with you is a sample class, and this particular sample class is described in terms of assessment that had 4 problems, but some of the problems had more than one part. So there was a 1, 1A, and 1B, 2A, 2B, 3A, 3B, 4A, B, C, and D. And so each of the parts of those problems were analyzed or evaluated by the teacher. Now if we look at this, we can see that this teacher has looked at item 1, And the teacher can see how many students were able to do well by item 1. So almost all the students except Daniel did fine by it. 1A, you can see there's a mix here. Noah met the criteria, and then you could see Nathan and Wes went above that. So this kind of item analysis allows us to look across to see how a student works altogether. So Noah in general met the requirements and had some exceeds as well, so Noah's doing all right. But we might get down to Daniel and see that Daniel's really struggling all the way across the board. So item analysis lets us look at how the class did in terms of particular math, which is useful for your analysis. So if this particular 1A and 1B was all about one topic, you can see, well, my kids did pretty well on it, and I'm okay by that. Or you can also see that sometimes one particular item, one particular math idea on the assessment, most of your kids did not do well on, and that's useful for your analysis as well. So an item analysis allows you to describe individual kids, but also your students' work across one particular idea. Now we want to hold on to the idea here that whoever did this one described Chloe in highlighted terms, David as well, and Yessie as well. And the reason to do this is that these are the 3 focus students, which are part of the essential work you do with this task. You have to define 3 focus students that you want to give a re-engagement lesson to. Now in this case, Chloe is pretty strong, and David is mixed, a number of concerns, and Yessie, there's a lot of concern here. But you might notice that under Chloe, whatever the question was for 4B, Chloe struggled with it, David struggled with it, and Yessie struggled with it. In fact, the whole class struggled with this, meaning that the re-engagement lesson might be a whole class lesson to work on the ideas that were in 4B. And that's essential to what you're going to be doing in the task, and I'll describe that a little bit more later. But hold on to that idea, it's important. So that's one way to look at the assessment and analysis. I'm going to give you a different way as well. And with this particular one, I'm going to take those ideas we just looked at, those scores that were on that item analysis are used to give students marks relative to this rubric up here. So based on the 4 criteria and the scores on the item analysis, students were given marks based on their work. So you can see Noah has a 2 for procedures based on the work that was done across that assessment under procedures, and 2 says uses procedures correctly but makes computational errors or other slight errors. So that's what Noah has here. But under concepts, if we go to the next level here, you can see that Noah did fine. Student shows clear understanding of the concept through representation and is able to apply the concept accurately. So this is a way of capturing students' overall work relative to your criteria set out here. And what's nice about this is you can also, again, do the kind of work you did with the item analysis. You can talk about individual students. You can say Noah's pretty much developing across the board. And you can see Bijou's doing well, and our friend Chloe's doing all right, but Niesi's having some struggles. Again, in your analysis you can look down the columns as well, and you can see relatively here that in some regards, problem solving, there were 3 3s, but there are number 1s and 2s. And you can look across any of these and say, well, which of these 4 criteria were the stronger ones for the whole class or the weaker ones? So let's put this away for now. I'm going to go now taking this idea. Let's think about those 3 students. Because the next part is, after we've summarized the class performance on the formative assessment completed during the learning segment, those kinds of charts I just shared, you want to analyze 3 focus students' work samples to identify targeted learning objective goal for the re-engagement lesson. Okay, so I've given some suggestion how you might find that. Now, in terms of writing that up, this is a good way to ground yourself in that. In the write-up, in your commentary, you'll have to be thinking about the 3 focus students. From your analysis of the whole class student learning, identify one area where students struggled mathematically. And then you want to select 3 student work samples that represent the struggles in this area. These students will be your focus students for this task. So I've shown you already how you can use the analysis tools that I shared to identify one area that might be worth redoing a lesson or setting out a re-engagement lesson for your students. In this write-up here, this is where you would describe the student's work and give a justification for that re-engagement lesson. Okay, so select 3 students' work samples that represent struggles in this area. This part, the struggles in this area, is the part that you're going to address through your re-engagement lesson. Now, this is a comment for all of the edTPA, but you can see that here as well. The most important thing you can do in the commentary is give good evidence throughout. So Chloe is being described here, and work from her paper is being written out here that you can see and reference completely straightforward to the work sample. So the work sample informs this part. And then having the good evidence, the teacher, the person who's done the evaluation, can give some justification for how that child's thinking and what kinds of work might need to be done to help the student with the area in which he or she is struggling in. And this is done for Chloe and for David and to Niesi. Okay? Evidence needs to be in here that sets up your justification for giving a re-engagement lesson about the struggles they had in a particular math area. So you've analyzed the 3 focus students' work samples, identified a target learning objective for the re-engagement lesson. All right. Now the next part. Write a re-engagement lesson that develops student understanding of the targeted learning objective goal. All right. So that should be clear. You're going straight from your analysis. Implement the lesson with the 3 focus students individually, in a small group, or with the whole class. Now, you're doing this whole class work around a particular topic if you want to. You could do it small group or individually, but however you do this, it has to be about these 3 focus students producing another work sample. So that's the most important part, because under the next bullet, collect and submit the work samples from the re-engagement lesson for the 3 focus students. And of course, the work you're going to be doing with that is to evaluate the effectiveness of the re-engagement lesson. So let's take a look at what the edTPA says you should be paying attention to in regards to this math assessment task. Here's what they say you should be focused on and care to do. If we look at this, we can see that the mathematics assessment task key points in terms of what to include are a copy of the actual assessment for the original learning segment. I've given you some examples of that. A graphic, table or chart or narrative summary of the performance of the class on the assessment from the original learning segment. And I would suggest a table or chart because you could see from the examples I shared with you how much more informative they were and how much more you can say about the whole class learning and about your 3 focus students from those. Include also 3 student work samples from the original learning segment and 3 work samples from the same students from the re-engagement lesson. Important note, think of these in terms of what the second set of 3 work samples is going to say about the teaching that was done to address concerns in the first 3 student work samples. All right? The re-engagement lesson is meant to help students with a particular misunderstanding or struggle, and that can be and their work samples will show the teaching, how that teaching set them up to do better by that math compared to the first 3 work samples. And then specific evidence from student work to support your evaluation of the re-engagement lesson. As I showed you in the commentary section, just use students' work verbatim and then give some analysis of what you see that comes straight from the work samples. And then according to edTPA, they suggest what to avoid. Significant content inaccuracies in your analysis. Make sure it makes sense. Your analysis should line up with your evaluation criteria and with students' results on their assessments. Also, to avoid targeted learning objective goal for the re-engagement lesson that is not aligned with the identified area of struggle. You have to find what they were struggling with and then address that thing, not something else. You're trying to make whatever was a struggle before better for students so they can get past it. And the next one, citation of evidence of student learning is not aligned with the student work samples. As I've been suggesting, evidence, direct evidence from the student's work. And the last one, reteaching without any changes the original lesson as your re-engagement lesson. The second lesson has to be about what students need to get better at in terms of the math that was on the first assessment. So if the lesson is very similar or is the same thing as the lesson that was done before, with the idea that maybe the students just needed more of it, that won't fly. It needs to be addressing the specific need the students have. So the scaffolds and the tools and models you might use in your math re-engagement lesson need to be about making kids better in the math that they might have struggled with. So I've gone through the what to-do list for the Mathematics Assessment Task 4, assessing students' mathematics learning. I've set out our friends here: conceptual understanding, computational procedural fluency, mathematical reasoning and problem-solving skills. I've given you some ideas around central focus and examples as well. We've talked about adapting assessments to make them worthwhile for your analysis. I've shown you some copies of students' work, the student assessments, and the kind of evaluation criteria that might go with them. And then we've talked about the analysis that sets up the re-engagement lessons. I hope this was helpful. I plan to come back and do a video also on the rubrics themselves. Using the rubrics as a way to start out your work and how to set yourself up for this task is very helpful as well. And say hello to my cat. Hope this was helpful. This is Johnnie.